And I'm going to hopefully present to you slides I've never presented internationally yet. This will be the first country to hear it. So hopefully you'll enjoy that as well. But I'm going to be talking in my first presentation about autoimmune disease or functional disorder. What is IBS? So we know IBS affects 45 million people in the United States and 1 billion people worldwide. About 10 to 14% of every population has irritable bowel syndrome, and is the most expensive disease in gastroenterology. And the reason it's the most expensive disease in gastroenterology is not because you do colonoscopy, it's because the Rome criteria. Because the Rome criteria said IBS is a diagnosis of exclusion, so you must exclude all of this and then diagnose IBS, which is where we were for a very long time. And then there's this notion that's changing now, this notion of the gut-brain axis, brain-gut axis. But I'd like to use this analogy that maybe the brain is just the check engine light. So you don't fix the problem by fixing the check engine light, you fix the engine. And so there's now this movement to say that everything is not a DGBI, disorder of gut-brain interaction. Under that term is achalasia. Is achalasia caused by the brain? Is fecal incontinence in a woman who had pregnancies and trauma to the pelvis and now can't contain the feces, is that a brain problem? So it's really too categorical, and so now there's a movement to change that terminology. And then there's 30 years of confusion. Now here's the amazing thing. For 30 years you were told, give a tricyclic to IBS patients because it's anticholinergic, meaning it's anti-vagus, meaning it's anti-communication to the brain. And now we say vagal stimulation. Vagal stimulation turns on the vagus. So which is it? Turn it off or turn it on? Or are we just confused? And I think the problem is we're a little confused. But there's some answers. And what I want to do now is to set this up for you is that we now know more about the cause of at least a part of IBS than we know IBD. You'll believe me when I'm done. Before I get there, tricyclics are harmful. For every 2.3 people who benefit from a tricyclic, one person has to stop it because they don't feel good, they feel side effects, they could have arrhythmias, etc., and you'll see some even more striking data on this coming soon. But what we want to get to is root causes. So what I'm going to show you in the two presentations is SIBO and EMO and ESO and these sort of notions of changes in the microbiome, the cause of IBS. But what I'm talking about now is not the leaves. I'm talking about the actual roots in the bottom. How does this all happen? How does the microbiome become bad or changed or SIBO? How does that occur? And we now know where food poisoning comes from. It comes from gastroenteritis. This is a meta-analysis of now 49 outbreaks in the various parts of the world. And what they show is that if you get food poisoning, that's when your IBS started. I was fine until I got Campylobacter, or I was fine until I got Salmonella or E. coli or Shigella. But now the number is 1 in 6.9. So if you went to a big wedding and everybody ate the buffet and the buffet had Campylobacter, 100 people at the wedding, 7 would leave that wedding with IBS almost forever. That's how bad that is. And we know this to be true now. But this is the more interesting study. Why? Because this looked at the deployment of troops to Iraq and Afghanistan between 2000 and 2010. Troops were going there, young women and men going to deployment. They didn't have IBS when they left, but many of them did when they came back. And they looked at what they experienced. And so for those who believe that psychological issues or psychological trauma are the cause of IBS, these people experienced death, they lost arms, they were in war zones. That's the kind of stress that most of us don't ever experience. And still it had no relevance. That's at the bottom. You can see it at the bottom. No relevance to the development of IBS. The only thing that mattered was, did they get food poisoning when they were in deployment? That's the only thing that determined whether they got IBS or not. So this actually proves that stress is not the cause of IBS, it's food poisoning. But here's the big one. In that study I showed you, the meta-analysis, Campylobacter is the worst. That's the number one. 1 in 5 people will develop IBS from Campylobacter. So we spent a lot of time studying Campylobacter, and I'll show you some data on what Campylobacter does. But Campylobacter now meets what's called the Bradford-Hill criteria. So there used to be Koch's postulates. Now the Bradford-Hill criteria are much more rigorous, and you have to meet all of these in order to say, this causes this disease, this bacteria causes this disease. And it now meets the criteria, and this was published in 2020. So, cause and effect. I'm going to talk about one small thing very quickly, and then I'm going to jump to what food poisoning is actually doing. We think that the food poisoning is leading to the overgrowth of bacteria. And a very important function of the gut is the cleaning wave or the migrating motor complex. So when you wake up in the morning, no coffee, no food, and your stomach is making the sounds, that's the cleaning wave. Every 90 minutes, it takes 15 minutes to come through, so it gets rid of the pieces of lettuce, things that you don't digest. You need this. And if you don't have it, even from 1977, they knew if you don't have this wave, you get bacterial overgrowth. So keep that in your mind. And this is what the wave looks like on high-resolution manometry. It's a very intense contraction that moves down the bowel like a dishwasher. So it's cleaning up your small bowel so it's nice and clean for breakfast tomorrow morning, because all night this is happening, cleaning up. But going back to food poisoning and how that wave is damaged, we know that 4 bacteria are the ones that cause food poisoning: E. coli, Campylobacter, Shigella, and Salmonella. But they're all different. They're very different, except they have one toxin in common, and that is cytolethal distending toxin, with B being the active toxin. So we did a series of studies where we were infecting rats with Campylobacter. They were getting IBS, they were getting overgrowth of bacteria in their small intestine. And then we said, well, could the toxin by itself do this? And we showed that it could. And we've shown this in a number of studies. This was a very important study. But basically that this toxin looks like you a little bit, and that this toxin looks like a protein in your body, and this protein, the particular one here, is on the deep muscular plexus interstitial cells of Cajal. Those are the cells that make the cleaning wave. And then you recognize that protein on those cells, and those cells go down, and then you don't get the cleaning wave of the gut. So it's basically molecular mimicry, that CDTB is making you form antibodies, and these antibodies then cross-react with you, creating autoimmunity as a part of the IBS mechanism. And we know that this is true mostly or almost exclusively for diarrhea IBS and mixed IBS, less for constipation IBS, although some patients do have these antibodies if they're constipated. So we helped to develop a test that you could do in humans. If you measure these 2 antibodies, anti-CDTB and anti-vinculin, can you diagnose IBS? And the answer is, if you have 2 people in the office with diarrhea, you can say one is IBS and the other is not for this test with high certainty. And especially you can diagnose it in comparison to Crohn's or ulcerative colitis, which were the other groups here. Now, I want to focus a little bit on this because this is the test dynamics. So post-test probability of over 80% is considered medical certainty for a test. So it meets that. But then people will say, well, the specificity looks great, 93%, but the sensitivity is 56% in the round circle. And you say, well, that's pretty low. But food poisoning as a cause of all the patients you call IBS only occurs in about 60%. The other part of IBS, we don't know what's causing it. So about 60% of IBS is accounted for by this. So my point is 56% is almost 60. So this is diagnosing post-infection IBS, not just IBS. Now this is really important because this is actually showing that the actual toxin causes the disease. So what we did in this study is we inject the CDTB toxin in the skin of the back of the rat like a vaccine. So not in the gut, not in the mouth. They get it in the back. And then they form antibodies because they were vaccinated to the toxin. And then they developed watery stool. And then the higher the antibody was, the more watery the stool was. And they developed changes in the microbiome. So I put a toxin in the back of a rat, and the gut physiology changed, and the microbiome changed. And it changed only in the small intestine, as you can see here. But what happened was, just like going to the wedding and getting Campylobacter, not all the rats got IBS. Some of them didn't, but then some of them did. And that's what this slide shows. So the rats that are in orange are the control rats, no toxin. The rats that are in green went to the wedding, got food poisoning, or got the toxin as a vaccine, but didn't change. The rats in blue did change, and they had elevations in E. coli in their small bowel, which we know is a hydrogen producer. The rats in the purple went in a different bad direction, more desulfovibrio, which produces hydrogen sulfide. This will be very important when we go to the next lecture later, when I start to talk about breath testing, because these are the two abnormalities, hydrogen or hydrogen sulfide in IBS. Now, these antibodies are also related to how many times you get food poisoning. So why is this important? So if you get food poisoning and now you have IBS and your antibodies are here, you better be very careful, because the next time you get food poisoning, they're going to be here, and the disease is worse, harder to treat. For example, when we talk about giving rifaximin later for the SIBO, it'll work if the vinculin antibody is here, but in the patients where it's very high, the damage is so much, the motility is so damaged that even the rifaximin will only make it temporary, and they will recur and recur and recur. And so we see that. But the more times you get food poisoning, the more high the antibody goes. So this is how I use the antibody test, as I do it in all of my diarrhea and mixed IBS patients, because it gives them an answer. Finally, I know what did it, I know why I have this disease, and also I know they have the disease. And if the antibodies are negative, then I'm going to look for other things, other causes for their symptoms. But this is what I wanted to get to for this talk, and I'm making this talk a little bit shorter because the other one is a little bit longer. These antibodies, we have now characterized all of them in humans, all the ones that are available in humans. We've sequenced them, and now we have them all phylogenetically characterized. Why? Because if I get rid of this antibody from the blood of a human, could we cure IBS? And I'll show you the answer to that in the next slide. When we do plasmapheresis, if we plasmapherese IBS patients, I'm not telling you to do this because it's very difficult, you have to put a central line in, but if you take out the antibodies or you give IVIG and get the antivinculin down, the IBS goes away. That's it. No antibiotics, no SIBO, none of that. You just get rid of this antibody and the IBS goes away. So there's a lot of work being done now, coming up in the next year or two, to develop a drug that could get rid of these antibodies and cure irritable bowel syndrome once and for all. So stay tuned for that. So in conclusion, I'm finishing early because the next talk is much longer. IBS is in part an autoimmune disease which affects about 60% of IBS that it is autoimmune. The term DGBI really doesn't apply anymore, especially as we're finding these new pathophysiological discoveries. Food poisoning causes IBS, for sure. And it's about 60%, as I mentioned, and now we understand that it does that and creates SIBO, as you'll hear in the next lecture. We now know the antibodies that are not just diagnostic tests. This is not a diagnostic test. These markers are causing the disease. It's different. So if you can get rid of them, you might make them better. And that's what the future holds. We're going to try to get rid of these antibodies. So that's it for this one.